Hi, I'm Marino Garra, and this is a video showing my project for Spawnfest 2022, which is called DTU, which means Data the Ultimate. The idea is that YAML is a really bad format for creating custom programming languages or domain-specific languages, and what if we create a data format that is better for that? Also, like a higher level problem is that we should make better tools for people that need to have a small embeddable domain-specific language, and a data format that makes it easy to translate to something or to evaluate maybe a good idea you can implement in a weekend. So I implemented this. I did it using Erlang as a programming language and Rebar for the project, Rebar format for the formatting. I used the standard library for lexing and parsing, and the translation I did it using the standard library pretty printer module. And for an example I will show later, I use the early web server, and the commands you want to run, you can run them manually, but you can also run them using just the command runner. The idea is that there's a standard and simple data format that is just data, but can be easily used to create domain-specific languages. It takes ideas from Clojure and, weirdly, if you think so, from XML. I think XML has two interesting ideas. The idea that a tag has a head attributes and like a tag name attributes as a head and then a body with children's. YAML doesn't have that, JSON doesn't have that. So I think we have to bring it back. And the other one is that it has namespaces. So the first, like literals, you have integers, you have floats, you have strings. From Clojure, you can tag literals or any data type or any node actually. And so, for example, if you want to say that this is a timestamp, you may tag it with TS. Tags have no meaning. Nothing has a semantic meaning in the DTU. The semantic is given by the translator or the interpreter. If I want to say that this is in kilograms, I can use fully qualified names that have like a namespace and an at and then the name. I want to say this is a regular expression, that this is a set or this is a date. Then we have names. You have seen names already in tags. You can have names by themselves. You can have a simple name, name with dots. And from Clojure, I'm not using the slash because I want the slash for division in expressions. So I'm using the at, which is from mails basically. So you can have foo at bar, at bar, or bus or whatever. You can even have emails with names. The idea is that this is kind of the module, and the thing on the right side is kind of the name identifier. And so it's name spacing. We have three types of collections. Again, they don't have any specific meaning. Even they can, like what can go inside, it's not defined. Any data from DTU can go inside any of the collections. You have to restrict what can go in on each and give them a semantic meaning on your dialect. It's not actually a dialect by the definition of dialect, is kind of the reverse. But yeah, so we have list with square brackets, tuples with parentheses, maps with curly brackets. But as you can see, in all of them, we can have literals, names, and even key value pairs. There's no particular restriction on that. So this could mean a set in your language. And or you can have like named attributes in tuples if you want. A node, you can also namespace the data types, the collections. This is like the anonymous tag for lists, but you can have a list that starts with something else. I think I have an example below. No, I don't. But if you like do like hash set and then the thing, yeah, I have it here actually. So here I'm basically giving it a tag to a tuple. So this is a set if that's what the meaning is given by the translator. Then we have nodes that are basically a name, then sequence in parentheses that usually it's called the head, which usually you put there your attributes. And then the body. You can have a node with only the head, with only the body, or with both. And what goes inside the head or the body is, again, defined by your format. But you can have something like this. And then alternatively, the body can be an alt body, which is a syntax to specify that the body is not a sequence, but a set of alternatives, whatever that means for you. It can be used for cond, for the switch statement, for a type that has multiple variants, whatever works for you. And finally, we have expressions. Expressions are like a left side, a symbol, and a right side. A symbol is anything that starts with any of these and follows with any of these, any number of them. And they don't have any meaning. There's no default precedence. Expressions are evaluated from left to right. If you want to give a precedence, use parentheses, because the symbols don't mean anything. So I cannot give them precedence. And also because it makes things simpler and forces you to explicitly specify the precedence. Here's an index of the code. We have the entry point for the script, the main, then the lexer, parser, the translator for HTML, for CSS, for JavaScript, for Erlang, and some utilities for pretty printing. We are going to go over them. So to exercise this idea, I created translators first for CSS. Here I have a quick example of CSS. I can go over here. I have some basic syntax highlighting. So I tried to cover as much as I could from CSS. I think I covered everything. So for example, I'm using mostly nodes with the body and key value pairs. I'm using names a lot. I'm using, for units, I'm using tags. So px 16 means 16 pixels, pc for %. I'm also using tags and tuples for RGB, RGBA, HSL, and HSLA. I'm using the hex on strings for hex colors. Again, my decisions were in a rush, so they may not be nice. But at least, for example, this one is much nicer. If you want to specify a var, you use a name that starts with var and then the name of the var. You can have strings. And for rules that have more than one value, you can either use a list or you can use this shorthand, which is basically a node with a head. So you don't have a key value pair, you just add padding and a list of the values and it will translate. And if you want to specify rules, for example, any of the following, and the ID result inside all is the asterisk, and or the class foo or the tag body have this rule. Like, don't try to interpret it, the content. I was just trying to cover things. If you want to try it, you can do just format CSS and it will translate it, and you can see the comments there, and you can read the just file. It's pretty easy to, if you don't want to install just, you just can see the comments here, and they map almost one-to-one. So this is the output. It looks like it is CSS actually, and you can see what it translates to. I'm covering almost all of CSS, and the things I'm not covering is because I couldn't think about them. Then we have HTML, the second one I tried. I like it more than HTML. It's pretty self-describing, but here's the first interesting thing. In the style tag, inside I write the CSS dialect of DTU. And we can see what it will do before saying it. It will call the pretty printer for CSS in that place, and will insert the output correctly indented and everything, because I'm using the same pretty printer library representation and even context, so it will be there as CSS and it will be indented correctly. So that's the first interesting part. Then I have like my body, my things. Then I can have inline style, which you can see here. It will also do the right thing. Somewhere over here. So if I have an attribute style with CSS, it will call the pretty printer, but it will render it inline in quotes. So it will do the right thing. And the second interesting thing that I already mentioned before is the third language dialect I implemented a translator for is JavaScript. This is kind of a mess because I was trying different features, so the code doesn't make anything meaningful. I will show you something that does later. But again, I have it here. I have the body, article, whatever, and then I start the script tag and I start writing the JavaScript dialect. And it will do the right thing. It will call the JavaScript pretty printer and will render JavaScript inline in there. With that, I wanted to write something that made sense and also to push me to implement the features needed to make something that made sense. So if I do just format to do MVC, it will output it into a file called to the MVC, which we can see over here. And you can see that it's HTML. It has, I forgot to implement our two rules there. I just noticed, but you notice that it has a lot of CSS that makes sense. We will see later, then some HTML, and interestingly, a lot of JavaScript. Well, a lot, yeah. Enough JavaScript to implement this. Let's start a HTTP server. Whatever is that? To the MVC. So now we can create a task, yet another, and I can mark one, I can filter active, completed, I can mark all as completed or none, I can mark one and clear completed, and I can remove. So basically to the MVC, all done in my language. Well, it's not actually a language, so all done in my data format, all in one single file. So basically 221 lines of DTU, all in one single format and only in one single file. And I had more time, so what I did is I started working on a dialect for Erlang, enough Erlang so I could run the almost hello world of Eli, the web server. So here I have like a module, I'm exporting some functions, including a library, defining a behavior, having a handle function with multiple clauses. Let's try it instead of talking. I have those instructions in the README. So if you go somewhere to the end, you can compile. I already did this, but I will run it for you, so you believe me it's a real thing. Then we can compile the Erlang to DTU, and we can open it. It's here. So you will see a mess here. I will explain. So we have the code, and then we have a string with some weird HTML and some more code. And that's because there I'm having I start with my Erlang, and then if you do a get to the root, you will receive as a result HTML that has some HTML, so that's to do MVC, that has some CSS and has some JavaScript. So basically I embedded 4 different languages in a single file. So this is a full stack data format where you can have a full application in one file using 4 different languages in 255 lines of code. So let's continue with the README. Now that I translated my code, I can start a shell, and I can compile my module, and I can start an Eli server. So now if I go to localhost 3000, I have my to-do MVC there. And that's interesting. And we can try it with curl, so I can, let me do it again. So now if I do curl to hello world, I get 200 hello world. If I do not found, and let's do the -v, I got 404 and not found. If I create a task, it will create it. It will return 201 and created. And here you can see that it's logging the name of the task. And yeah, and the other one is if you do curl / it will return the HTML. So basically that's the LE server handling get and post and get and returning HTML, and all in a single file. That's the core idea of DTU, and it's presented here. Again, it's implemented using Erlang, and I think the core idea was proven. I would make some changes to the parser, but I found out halfway and I didn't have enough time to make them. But it can like express a real application, front-end, back-end, HTML, CSS, and JavaScript, and I could write for like translators for enough parts of each language to have a real application in 255 lines of DTU, including the backend. So yeah, this was my project, and I hope you find it makes any sense. So it's at Spawnfest /DTU for now. Bye.